Welcome, Standard 11th Science students, subject Mathematics, paper 2nd, lesson number 9, Differentiation. To learn concept in the lesson Differentiation, first, meaning of rate measure, second, definition of derivative and formula associated with it, then derivative of some standard functions. Next, relationship between continuity and differentiability. These concepts to learn in this lesson. Introduction part for a lesson differentiation. Suppose we are traveling in a car from Mumbai to Pune. We are displacing ourselves from origin, that is from Mumbai to the Pune, from a time to something. We know that average speed of the car is equal to total distance traveled divided by time taken to complete the distance. But at different times, speed of car can be different. It is the ratio of very small distance traveled with the small time interval required to travel that distance. The limit of this ratio as the time interval tends to 0 is the speed of the car at that particular time. We are considering here smallest distance and smallest time for a ratio. This process of obtaining the speed is given by the differentiation of distance function with respect to the time. This is an example of derivative or differentiation in our daily life. This measures how quickly the car moves with time. Speed is the rate of change of distance with respect to the time t. This definition you have already learned. When we speak of velocity, it is the speed with the direction of movements. In problems with no change in direction, words speed and velocity may be interchanged. The rate of change in a function at a point with respect to the variable is called the derivative of the function at that point. Mathematical definition. Process of finding this derivative is known as differentiation. Process of finding derivative known as differentiation. Let us see in details. Definition of derivative and differentiability. First, let fx be a function defined on open interval containing a particular point a. Function fx is defined on a particular interval, whatever the given a to b. In general, we are saying, suppose a is a particular point in that interval. Limit delta x tends to 0 for f of a plus delta x minus f of a divided by delta x. Limiting value exists, then f is said to be differentiable at x is equal to a. That is differentiability at a particular point x is equal to a, where this delta x is a small increment in variable x. Check here. Limit is said to be derivative of fx at x equals to a. Symbolically, it is denoted by f dash of a. We calculate derivative of function f at any point x in the given interval, that is from the domain of the function f. Let y equal to fx be a given function. Let there be a small increment in the value of variable x. Increment in the variable x is expressed as delta x. Then the correspondingly there will be a small increment in the value of y. that is taken as a delta y plus delta y is equal to f of x plus delta x. Check function y equal to fx be a given function. Increment value expressed as y, increment is delta y, so y plus delta y. And in x variable, increment is delta x, so right hand side f of x plus delta x. To express in terms of limits for the definition of differentiation, plus y shifted to right hand side getting minus y, but y is a function in terms of x, that is fx, replace y by fx, then dividing both the side by small increment delta x. After that, this delta x value is not equal to 0, so we are dividing by delta x, then taking limit delta x small value as it tends towards 0 on both the sides. After taking limit on both the side, this delta y upon delta x limit delta x tends to 0. If this limiting value is exist, then that is called as derivative of the function. Symbolically, derivative denoted by dy upon dx or f dash of x. Limiting value for delta y upon delta x tends to 0 exists. It is expressed as dy upon dx or f dash of x. Anyway, you can use any symbol as per your choice. Remember here concept, if y equal to fx is a differentiable function of x, then limiting value denoted by dy by dx, that is a derivative. And second, f dash of x, that is limit delta x tends to 0 of x plus delta x minus fx divided by delta x. This is also known as a first principle of derivative. Delta x small value consider as a h in this limiting function. We can express it as limit h tends to 0 f of x plus h minus fx divided by h as a f dash of x. It exists, that is derivative exists. And next line given here, h tends to 0 minus and h tends to 0 plus limiting values. That is value for the derivative from left hand side and derivative from a right hand side. Meaning given in the next line, h tends to 0 minus of f of a plus h minus f of a divided by h, called as left hand derivative at x equal to a. And limit h tends to 0 plus of f of a plus h minus f of a divided by h as a right hand derivative at x equals to a. Check here, left hand derivative denoted by L f dash of a or f dash of a minus. Same way, right hand limit is denoted by R of f dash a or f dash of a plus. These are the notations for left hand derivative and right hand derivative. Existence of derivative, both derivative values are equal. Then we say that derivative exists. Let us continue for differentiability by method of first principle. Just seen definition in terms of limit for a derivative of function fx. Check here, definition already seen for f dash of x as a h tends to 0, f of x plus h minus fx divided by h in the previous slide. Derivative also denoted by dy by dx. This is called as a first principle. Derivative or a first principle value at particular point x is equal to a, that is x value is replaced by a particular point a, f dash of a is obtained, limit h tends to 0, f of a plus h minus f of a divided by h, that is answer of dy upon dx at x equal to a. Derivative of standard functions, in that first one function is a power function. Function fx is expressed as x raised to n power, that is degree. Then neighborhood value f of x plus h, x is replaced by x plus h, right hand side change to x plus h bracket raised to power n. To find out derivative by first principle, applying formula of first principle derivatives, f dash of x as a limit h tends to 0, f of x plus h minus f of x divided by h. Check here. Limit h tends to 0 of f of x plus h value, that is x plus h raised to power n. Fx value is x raised to n, substitute. Then power n, we can use binomial theorem for the power. Two terms are here, x and h. Let us see simply binomial expansion. X plus h raised to power n only. X raised to n plus nc1 x raised to n minus 1 h raised to 1, that is h, plus next coefficient nc2 x raised to n minus 2 h raised to power 2, plus dot 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 dot, last one become ncn value is 1 into h raised to power n. Substitute in this limit value for the bracket. And last one minus x raised to n as it is. Check in calculation, plus x raised to n and minus x raised to n get cancelled. And then remaining terms in the expansion, each term contain h value as a multiple. We can take common h from these remaining terms. H common taken, first one remaining is only nc1 x raised to n minus 1, then nc2 x raised to n minus 2 into h raised to 1, and last is h raised to n minus 1. H common taken, then denominator h and numerator h get cancelled. Remaining terms in the limit as it is, h tends to 0 of nc1 x raised to n minus 1 plus nc2 x raised to n minus 2 h raised to 1. Now put limit as a h tends to 0, that is value of h as a 0. Check second term, third term up to last term contains h value. So all these terms getting 0 except first. So answer is nc1 x raised to n minus 1 plus 0 up to last one also 0. But value for nc1 by combination formula, you will get answer as a n multiplied x raised to n minus 1 as it is. This is the value for f dash of x, that is derivative of function fx x raised to n. Its answer is n times x raised to n minus 1. Also expressed as derivative d by dx of function x raised to n. Answer is n times x raised to n minus 1. First problem you have seen for derivative of a power function.